Welcome to Neurolabit, where we talk about everything that is interesting and exciting about the brain and AI. I'm an AI assistant working with Bo, who is a Swedish neuroscientist and data analyst. Bo has written the video manuscript and is controlling the visuals in the video. Today we are going to talk about how the neurons in your brain can create your consciousness. Right now, you're having a thought. Maybe you're wondering how you're watching this video, or why your brain even knows it exists. But have you ever stopped to ask, what exactly is a thought? And how do billions of neurons, firing silently inside your skull, produce something as rich and mysterious as consciousness? Today, we're diving straight into the neural matrix to find out how the brain turns electricity into experience. So what theories of consciousness are there? It turns out that there is a whole bunch of them. So it can be daunting for the average person to even start thinking about theories of consciousness. This is why we need scientists to help us understand. Unfortunately, in recent years, scientists have emerged presenting pseudoscientific theories of consciousness that have gained popularity. It's a breach of conduct for a scientist to present pseudoscientific ideas in a way that makes it seem like the theory has a lot of scientific evidence to back it, when it clearly has not. This video aims to help clarify these scientific gray zones so that fewer people are led astray. I will go through the 3 best theories with the strongest scientific evidence, as well as the 2 worst theories with the weakest evidence. First up is global workspace theory. Proposed in the 1980s by cognitive scientist Bernard Baars, global workspace theory suggests that consciousness works like a theater. Most mental activity happens backstage, invisible to us. But when a spotlight hits, that's when we become aware. In this metaphor, unconscious processes compete for attention. The one that wins is projected onto a mental stage, the global workspace, where it becomes available to the entire brain. Language, memory, reasoning, motor functions, all can now access that information. In neuroscience terms, the workspace is not a single location, but a dynamic pattern of activity that spreads across many regions, especially the prefrontal and parietal cortices. This wide-ranging activation allows the brain to coordinate, plan, and report. Experiments back this up. When we become aware of the stimulus, brain scans show a sudden, synchronized burst of activity, a phenomenon scientists call global ignition. Without it, the same stimulus remains unconscious. Global workspace theory explains how information becomes conscious, but not why it feels like anything. It maps the functions, but doesn't resolve the mystery of subjective experience. That's the so-called hard problem of consciousness. Global workspace theory has transformed how we study the mind. It gives us a language to talk about consciousness, not as magic, but as a real, functional process within the brain. And in that process, perhaps, we see the first lights of understanding what it means to be aware. We now move over to integrated information theory, developed by neuroscientist Giulio Tononi. Integrated information theory, or IIT, offers a bold idea. Consciousness is nothing more and nothing less than the ability of a system to integrate information. Here's the core idea. A system is conscious if it has causal power over itself, in a way that's both informative and integrated. The more tightly the parts of a system work together, the higher its level of consciousness. IIT introduces a measure, phi. This number estimates how much information a system integrates. A high phi, rich conscious experience. A low phi, less or none at all. For example, a sleeping brain, low phi. A dreaming brain, higher phi. A digital clock, near zero phi. No consciousness. Take a photodiode. It reacts to light, but its response is simple, isolated. It doesn't integrate information. A human brain, in contrast, connects billions of neurons in patterns too complex to simulate. That complexity is what gives rise to consciousness, according to IIT. Here's where it gets controversial. If consciousness comes from integration, then any system, biological or not, could have some level of it, even a thermostat or a computer circuit. This idea edges toward panpsychism, the belief that consciousness is a fundamental aspect of all matter. IIT doesn't just describe consciousness, it tries to model what each conscious moment is. In IIT, every experience is a unique shape in qualia space, a mathematical structure of relationships. Could we one day build machines that are truly conscious? Could we detect consciousness in patients who can't speak or move? If IIT is right, we may be able to measure these mysteries and one day answer them. Integrated information theory offers a daring vision of consciousness, not just as something humans have, but as something that exists wherever information becomes whole. Whether it's truth or metaphor, it challenges us to rethink the boundaries of mind. The third theory with good scientific evidence is integrated attention-schema theory. You see the world around you, you know you're aware, but what exactly is that knowing? What makes you conscious of your own mind? One theory says it all comes down to how your brain models attention itself. Integrated attention-schema theory, or IAS, was proposed by neuroscientist Michael Graziano. It combines two key ideas: attention, the brain's ability to focus on specific information, and schemas, internal models the brain builds about itself and the world. Attention is the brain's mechanism for enhancing certain signals, like a spotlight highlighting specific details while leaving others in the dark. It's how we select what's relevant and suppress what's not. But here's the twist. Graziano argues that the brain doesn't just use attention, it models it. Just like it builds models of the body for movement, it builds an attention schema, a simplified internal map of where attention is directed and what that means. According to IAS, consciousness emerges when the brain constructs a model of its own attention. In other words, you feel aware not because of some magical property, but because your brain represents you as being aware. This model doesn't need to be accurate, it just needs to be useful. That model gives rise to the illusion of subjective experience. Just like a computer thinks it has a user, we think we have a mind. It's the brain modeling the brain. Why would evolution favor this? Because modeling attention, ours and others, is a social superpower. It lets us infer intentions, read minds, and navigate complex interactions. Awareness, then, is not a bug, but a brilliant adaptation. Research shows that brain regions like the temporoparietal junction and prefrontal cortex are active when we report awareness, exactly the areas implicated in building internal models. Unlike global workspace theory or integrated information theory, IAS doesn't rely on massive networks or mathematical complexity. Instead, it focuses on how the brain models itself. It's computationally efficient and testable. Critics argue the theory explains the report of consciousness, but not the experience itself. Is a model of attention really enough to create qualia? Or are we just describing behavior, not inner life? Integrated attention schema theory offers a powerful idea that awareness is the brain's self-modeling of attention. It may not solve the hard problem, but it gives us a clearer lens to understand how consciousness might emerge from nothing more than information, focus, and feedback. I will now go through two theories with very weak or no scientific evidence. The first one is idealism. What if the physical world doesn't really exist? What if everything, including you, me, and the universe, is just a ripple in some kind of cosmic mind? That's the bold claim of idealism, a theory of consciousness that turns science on its head. Idealism is the idea that consciousness is fundamental, that matter, space, and time are illusions or constructs within mind. The external world, according to this view, doesn't exist independently of our perception. In the 18th century, philosopher George Berkeley famously wrote Esse est percipi, to be is to be perceived. His solution to reality? God is the all-seeing perceiver, maintaining the universe in consciousness. Modern science moved on from Berkeley's theology, but idealism never fully disappeared. Today, a small but vocal group of thinkers are bringing idealism back. Philosophers like Bernardo Kastrup argue that the universe is a mental construct inside a universal mind. Donald Hoffman, a cognitive scientist, goes further, claiming space, time, and physical objects are like icons on a desktop, useful illusions, not reality itself. But here's the problem. Idealism lacks testable evidence. There are no falsifiable predictions, no controlled experiments, no measurable quantities that distinguish it from dream or fantasy. Unlike theories in neuroscience or physics, idealism offers no mechanism for how consciousness could generate the detailed structure of the physical universe. So why does it attract attention? Idealism has intuitive appeal. We're all conscious. Every experience we have is mediated by the mind. It's tempting to think, maybe mind is all there is. And yes, dreams, hallucinations, and simulations show we can have rich experiences without corresponding physical causes. But that doesn't prove the external world is imaginary, only that the brain can be fooled. In science, theories must do more than sound profound. They must be predictive and testable. Idealism offers neither. It often reinterprets physical facts post hoc, while rejecting the need for physical causation altogether. Even within philosophy, idealism raises major questions. If only mind exists, whose mind is generating this consistent, shared reality? Why does the world follow mathematical laws? Why does consciousness appear to vanish under anesthesia or brain damage? Neuroscience offers more grounded theories, like global workspace theory or integrated information theory, that link consciousness to brain activity without assuming that mind creates matter. These models have their own limitations, but unlike idealism, they're being tested in labs using real data. Idealism is provocative, it's imaginative, it may even offer insight into our inner lives. But when it comes to explaining the external world, the structured, measurable, mathematical universe we all share, it simply doesn't deliver. For now, it remains a philosophical lens, not a scientific theory. The final theory that we will talk about is called Orchestrated Objective Reduction. Roger Penrose, a Nobel Prize-winning physicist, believes consciousness doesn't come from neurons, but from the very fabric of the universe, from quantum mechanics. But is it science or just science fiction? The theory was created in the 1990s by physicist Roger Penrose and anesthesiologist Stuart Hameroff. At the core of OR is the idea that quantum superpositions, where particles exist in multiple states at once, occur inside tiny protein structures called microtubules. Penrose proposed that these superpositions undergo a kind of natural collapse, called objective reduction, which is not random, but somehow tied to the fabric of reality itself. When this collapse happens, suddenly, a moment of consciousness occurs. OR doesn't just say the brain uses quantum mechanics. It claims that consciousness itself is a quantum phenomenon, potentially tied to quantum gravity, one of the least understood forces in physics. It's bold, it's fascinating, but is it testable? The biggest challenge? Quantum coherence, the delicate state needed for quantum computation, doesn't last in warm, wet environments like the brain. Experts in quantum physics have long argued that the brain is far too noisy for quantum states to survive long enough to do anything useful. As physicist Max Tegmark calculated, decoherence would occur in femtoseconds, far too fast for any brain process. Despite decades of discussion, there is no direct experimental evidence that microtubules perform quantum computation, let alone generate consciousness. No observed quantum states in brain microtubules. No testable predictions that distinguish OR from known neurobiology. So why does it still get attention? Because it's seductive. It brings consciousness into the realm of fundamental physics, implying that the mind is woven into the structure of the cosmos. And with Roger Penrose's reputation, especially after winning the Nobel Prize in Physics, people listen. But prestige doesn't replace empirical support. Hameroff, an anesthesiologist, argued that anesthetics disrupt microtubule function, possibly turning off consciousness. But neuroscience already explains anesthesia through well-understood receptor dynamics and neural network suppression. No quantum explanation is required, and none has been verified. Current neuroscience links consciousness to emergent activity across neural networks, not subatomic particles. Theories like global workspace theory and integrated information theory offer testable models that align with actual brain data. Orc-OR, in contrast, remains theoretically speculative and empirically unsupported. Orc-OR is imaginative, it's daring, but nearly 30 years after its proposal, it still stands more as philosophical conjecture than scientific theory. Until there's clear, reproducible evidence of quantum consciousness, Orc-OR remains what it began as, a fascinating idea, but one that science hasn't validated. You've reached the end of the video. Please let Bo know your thoughts about these theories of consciousness. Also, don't forget to like the video and subscribe to the channel. Goodbye.